So elasticity connects together with revenue. Total revenue is price multiplied by quantity. From that demand curve shown, for any price in the market, there's a certain number of X demanded, and when these are multiplied together, that's the area of the box, shaded pink here. If a business sells 8 items at $30 each, their revenue is $240. Simple enough. What's the connection to elasticity? If I lower the price, what happens to revenue? Business puts on a sale, they lower the price, they charge. Is that good? A lower price means less revenue per item sold. Lowering the price means the business is not going to get as much money on everything they sell, but they'll sell you more units. Is that good or bad? Let's make these easy numbers for now. A business sells 100 Q at price equals $1. So revenue is 100. That's Q times P. If the business sets a price of 99 cents and sells 110 Q, is that better or worse? Well, changing the price from $1 to 99 cents means that they make a penny less on everything they sell. But if they sell one more, then they can make it up. A penny less on the 100 that's sold means a total of $1 less. But if they sell 10 more at 99 cents each, that's $9.90 more in revenue. That's net good for business revenue. Now, is such a large effect plausible? Yeah, retailers know the consumers are kind of fooled that way. If we think about it for even a moment, we know in our mind there's only a penny difference, but sometimes it just feels different. But on the other hand, if they drop the price to 98 cents and sold 111, was that next penny drop worthwhile? Well, they lose a penny on 110 items, so revenue is down by $1.10. They sell one more item, so revenue is up by 98 cents. That's a net loss. It all depends on how much the quantity changes, therefore. That's elasticity. Now, one of the key assumptions I'm making is that this is a commodity. It's undistinguished and homogeneous. The person selling cannot charge a different price to different buyers. Now, obviously, businesses work really hard to try to set different prices for different buyers. Websites use your browsing history, even your operating system, to change the price that they'll show you. There are astonishingly complicated algorithms behind trying to wring a few extra pennies out of each one of us. Anyway, going back to the graph, here's the same pink box of revenue, but now the business has lowered the price, so that's delta P off the box. Got smaller by the vertical distance. But the revenue box also got wider as more units are sold. So the net change to revenue depends on the relative sizes of delta P and delta Q. The change from the pink box to the green box is the green box is shorter by that slice at the top, but wider by that slice on the side. Elasticity demand curve shows the relative sizes of those slices. If the demand curve were very steep, so there's not much of a change in quantity, then revenue would be shorter, but not much wider, and smaller box on net. If demand curve were flat, then that would be a lot change in quantity. Revenue would be shorter, but a lot wider, and grow on net. That's exactly what the formulas tell us. Total revenue, TR, is the price, P, times the quantity. With a bit of calculus, you can take the log of both sides and then take the derivative, remembering that the derivative of the logarithm is the percent change. So percent change in total revenue is percent change in P plus percent change in Q. That's all a bit of mathematics, but it's useful in the world. Here's a sign I saw up in Maine, a sort of dollar store. Not an official dollar store, that's a trademark name, but kinda. Anyway, apparently they had some problems. They weren't bringing enough revenue, so they tried to be a 50-cent store. You can see that price below. They dropped most prices in half. Do you think that generated sufficient change in total quantity? They'd have to sell twice as many items at half the price just to keep revenue the same. Spoiler, next time I drove by, the store was closed and there was a sign for rent. So clearly, not. I think with a bit of reflection, you could have guessed that. For most consumers, there's not a huge difference between a price of $1 and a price of 50 cents. And people might buy a little more at the lower price, but not twice as much. Anyway, economists love elasticity. We love it so much. We use it all the time. Humans in general are not very smart. When we get a good idea, we use the heck out of that good idea. Elasticity of demand is a good idea, so we keep using it in various variations. There's elasticity of demand, and there's elasticity of supply. Instead of looking at changes along the demand curve, we look at changes along the supply curve. As, for example, olive oil prices rise, how much more olive oil will be produced? Now, again, there are time dimensions. In the short run, not much more. In the long run, might be more sensitive to price changes. We can define the cross elasticity of if coffee prices change, what happens to the quantity of donuts sold? We have to talk about income elasticity. If people have 1% more income, how much more do they spend on different items, such as wine? Most likely they step up in quality purchased, even if quantity not so much.